As explained at the beginning of the chapter, when we integrate the marginal function, we will obtain a generic function plus a constant. However, the specific original function requires one more additional specification, which is known as initial condition. This is a specific value that the function takes at a particular value of x, which in this case is equals to m. Having the marginal function and the initial condition allow us to obtain the specific original function and the particular value that the constant c takes. In order to do that, first, we compute the indefinite integral as before, and second, we will plug the value of the initial condition, and as a result, we will have an equation that we will solve, and in that way, we will find the value of the constant. To understand this mechanism, let's solve the following example. Here we have the initial value condition and the marginal function. First, we will integrate the marginal function to obtain the generic function. This is the integral of 18x to the 5 plus 4x to the minus 3. Here we can separate these two terms into two integrals. And now let's proceed with the integration of each term. Here the constant part is 18. The integral of the variable part, which is x to the 5, is x 5 plus 1 is 6. Therefore, we will divide also 18 by 6 plus, here the constant part is 4 times x. The integral to the x minus 3 is x to the minus 3 plus 1. So this is going to be minus 2. And therefore 4 will be divided by minus 2 plus c. So this is going to be equals to 3x to the 6. 4 divided by minus 2 is minus 2 x to the minus 2 plus c. And this will be our original function f of x. The second step is to plug the initial value condition. Here we have that when we plug x equals to 1, the original function will be equals to 8. So let's do that. When we plug f of 1, this is going to be equals to 3 times 1 to the 6 minus 2 times 1 to the negative 2 plus c equals to 8. So this now is an equation because 1 to the 6 is 1 times 3 is 3 minus 1 to the minus 2 is 1 times 2 is 2 plus c equals 8. 3 minus 2 is 1. This means that z is equals to 8 minus 1. This is 7. Now that we know that our constant is 7, our specific function has been recovered. F of x is 3x to the 6 minus 2x to the minus 2 plus 7. And this is the solution for this problem.